All right, guys, we're moving on to a new chapter. The nice thing about this chapter is it's very similar to the last chapter. Well, at least this section is. Uh, the only thing is we're taking the policies that we learned about linear functions in the last section and we're applying them to quadratic functions. So a quadratic function is a function that can be written in the form of f of x equals a, which is just some number, times x, that's our variable, minus h squared plus k. In a quadratic function, the variable is always squared. So no matter what, my x always has to be squared in order for it to be considered a quadratic. We kind of knew that from the last section. I mean, we went through our parent functions, and quadratics had the x squared every time. So we kind of knew that about the x. It's got to be squared. Now, if we're looking at the linear and quadratic parent functions, linear function we learned in the last section, that was our straight line. Quadratic is always going to have this U shape to it. In our standard quadratic parent function, and this is nice because you can always refer back to this table, but in our standard quadratic parent function, when x is negative 2, y is 4, or f of x is 4, negative 1, f of negative 1 is 1, 0 is 0, 1 is 1, 2 squared is 4. So that's how we form our parent function. Graphing quadratic functions using a table. So this is the first way that we can graph quadratic functions. We can plug some values in here and graph those values. So if I plug those values into the equation, I start by putting a 0 in. F of 0. Now if I put that 0 in there, that's not multiplying or anything. It's just telling me that the function of 0 means I plug a 0 in every time I see an x. 0 squared is 0, minus 4 times 0, that's also 0. This would be 3. So if I'm looking at my graph, it would be 0, 3. Plug the 1 in. F of 1 would be 1 squared minus 4 times 1 plus 3. 1 squared is 1, minus 4 times 1, that would just be minus 4. That's negative 3 plus 3, 0. So now I have 1, 0. Plug the 2 in. 2 squared minus 4 times 2 plus 3. 4 times 2 is 8. 2 squared is 4. So it's 4 minus 8, negative 4 plus 3. That's negative 1. Move on to 3. F of 3 equals 3 squared minus 4 times 3 plus 3. 4 times 3 is 12. 3 squared is 9. 9 minus 12 is negative 3 plus 3. That's 0. And then f of 4. This last one is 4 squared minus 4 times 4 plus 3. 4 times 4 is 16. 4 squared is 16. 16 minus 16 is 0. Plus 3 is 3. So I have 4, 3. Now I can graph this using that table and go into my Desmos. And I can just plot those points. 0, 3, 1, 0, 2, negative 1. So when I look at this, I see my U shape. If this was a homework question, you could sign in like I am You could save this graph as question 1. Better yet, you could save it as 1.1, 2.1, the name of the section, question 1. Save. Click this button, copy the link, send me the link either in a document or you can just put it in the private comments of your homework. So if you write it down on paper, which is how I want you to do it for the millionth time, I don't want you to mess with Cami. I don't want you to mess with Google Docs. Write it on paper. Then your graphs you can just paste in your private comments. So even if I close this out, all I have to do is paste my link in. It brings my graph right back up. Okay, enough preaching about that. But that's my quadratic function. I want you to try this one. You are going to graph negative x squared plus 6x minus 8. Since I know you're doing this on your own, f of 0 equals negative 0 squared plus 6 times 0 minus 8. It gives me 0, negative 8. Plug the 1 in. F of 1 equals negative 1 squared. Now because my negative is out in front here, it doesn't mean I'm squaring negative 1. Order of operations. I do the 1 squared first, and then I make it negative. Plus 6 times negative 1 minus 8. 1 squared is 1. Negative makes it negative 1. Minus 6, that's negative 7. Minus 8 is negative 15. So 1 and negative 15. Plug the 2 in. 2 squared, that's negative, plus 6 times. Oh man, I messed this up. I put a negative 1 in. I should have just made that positive 1. Because the point I was plugging in was 1. Let's go back and fix that. Because that's going to change my answer. Positive 1 minus 8. 6 times 1 is 6. Minus 8, that's negative 2. Minus 1 is negative 3. Better now. 6 times 2 is 12. 2 squared is 4. That's negative 4 plus 12. That's negative, or that's positive 8. 8 minus 8 gives me 0. So this is 2, 0. F of 3 6 times 3 is 18. 3 squared is 9. Negative 9 plus 18 gives me 9. 9 minus 8 is 1. And now we do f of 4. Six times 4 is 24. Minus 16, that's 8. 8 minus 8 is 0. Let me go back in my graph. I should start a new one. And then put my points in. 0, negative 8, 1, negative 3. If you're like me, you're lazy. I'll copy this and then enter it in a bunch of times. Just so I don't have to retype my parentheses and comma. I can just go in and change this. Each number 0, -8, then 1, -3, 2, 0. Wow. 3, 1, 4, 0. Okay, now whenever I look at this one, I can see it comes up, stops, and then goes back down. This doesn't quite form a parabola. I mean, it's the right shape as a parabola, but I'm missing a dot over here. That's because my numbers weren't centered. I had 1, 2 before the top point, and then this one was directly after it. So I had 3 before it and 1 after. So because I wasn't centered, it makes it so it's hard to see, but this actually continues to be a parabola because it's a quadratic. You can also graph quadratic functions by applying transformations to the parent function. As we go, it's going to be too much work to be plotting points all the time. To plug values into these functions nonstop is just not feasible. So we're going to use the transformations that we did for linear, and we're going to apply them to quadratics. As far as horizontal translations, we have a horizontal shift of h units if the x minus h or the number is inside the parentheses. So if it's inside the square, like everywhere I see an x, I would now put x minus h, or whatever number that ends up being for h. So that's how we do a horizontal shift. If it is less than 0, or if the number we're subtracting is less than 0, then that makes it move to the left. In other words, if I'm adding a number inside of there, it's going to be moving left, because h would be less than 0, so it would have to be negative. Minus a negative makes a positive. So if this number on the back side of this number here, if this is plus 3 or plus 4, it moves it left. If it's minus something, it moves it to the right. Vertical shift of k units, that goes on the end, outside of the parentheses. You'll notice the plus k here is outside of the parentheses, and that's the same as it was for linear. It moves up if it's positive. If it's plus a number, it goes up. If it's minus a number, it goes down. Every single time. Use the graph of f of x equals x squared as a guide. Describe the transformations and then graph each function. So we don't need to graph the function to get started. All we actually need to do is look at what our transformations are telling us to do. When I look at those transformations, I can see that something is happening inside the squared and something's happening outside the squared. Those two things tell me exactly what I need to know about the translation. Minus 2, it's a minus inside the parentheses. It means we move right 2. So the parent function is going to move right 2. The plus 4 means it goes up 4. Now it says graph each function. So let's graph it and see if we're correct. Just go new blank graph. We'll first graph x squared. Now let's do our parentheses, x minus 2 squared plus 4. So the red is my original, or my parent function. It's at 0, 0. I said my new graph is moving right 2 and up 4, so my new point should be at 2, 4. When I click that, you can see that this is 2, 4. So it was right. I want you to try this one. Use the graph of f of x equals x squared as a guide. Describe the transformation. Here, this starts as a plus 2. Whenever you have a plus 2, it means that it's moving left. The minus 3 means that it's moving down. So we're going left 2 and down 3. If we need to graph that, we can absolutely do that. As soon as I stop writing on the thing. Plus 2, and this was minus 3. Looking at this graph, and my original one, it started at 0, 0. Now it tells me that this one is at negative 2, negative 3. Move left 2 and down 3. Those are translations. We will pick up there with the other types tomorrow.